Day 65 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again another day, another LeetCode problem. I hope you guys are excited about it. I hope you guys are still motivated, and I hope you guys are still staying disciplined, guys, because it's discipline that's going to get you through this and help you to learn. Without discipline, you could forget this easy, and that you could forget what you learned today by next week if you don't stay disciplined and continue to build on your knowledge every day, guys. That's how hard and how serious this stuff can be, guys. It is not easy, but don't let that deter you, guys, because everybody goes through the same struggles when it comes to programming, and we're all trying to learn, guys, and we all have to stick to it if we want to learn something. If we give up, we're just going to give up, but we're not those type of people. We're swift programmers. We don't give up. We keep going and going and going, guys. So I hope you guys are still motivated, and I encourage you to stay disciplined because it will pay off one day. Now, with that being said, guys, don't forget, bring your mouse right over here, guys, and click that subscribe button for me. Then after you click that subscribe button for me, go ahead and smash that like button for me, guys. Then after you smash that like button for me, go ahead and drop that bank emoji in the comment section. I need all of my bankers out there to go ahead and drop that bank emoji in the comment section so we can run this engagement up and bring more awareness to the Swift community and help grow this Swift community as a whole. Now, let's see what question we have here today. Today we have question number 2542, maximum subsequence score. The difficulty level is medium, guys, but you know we're going to keep the solution as simple and easy to understand because we're all learning, and an important part of learning is understanding the solution that you're writing or understanding the code that's being written, guys. And in order to understand the code, first, you need to understand the question. So let's read the question and break that down. It says, you are given a 2 index integer array nums and nums2 of equal length n and a positive integer k. You must choose a subsequence of indices from nums1 of length k. For chosen indices I0, I1 up to ik minus 1, your score is defined as the sum of selected elements from num1 multiplied with the minimum of selected elements from num2. It can be defined simply as nums I0 plus nums I1 plus all the way up to nums2 ik minus 1. Return the maximum possible score. A subsequence of indices of an array is set that it can be derived from the set 0, 1 up to n minus 1 by deleting some or no elements. Okay, guys, let's break that down because as per usual, the question's a little hard to understand. So let's look at these examples because it's really not that hard to understand once you understand it, if you know what I'm saying. So let's break it down. We have an input of nums, an array of integers 1, 3, 3, and 2. Then we have nums2, another array of integers 2, 1, 3, and 4, and k equals 3. The output is 12. So let's break this first part down. First, we have k equals 3, right? So we have to pick 3 elements to create our subsequence, and then we have to multiply that by the minimum of the other 3. So let's look at the explanation to break that down a little more. It says the 4 possible subsequence scores are. So let's say, k equals 3. So it says first we choose indices 0, 1, and 2 because that's k equals 3, and those are the 3 indices we picked. Now we have to pick the same 3 indices in nums1 that we pick in nums2, right? So right now for this first example, we're going with indices 0, 1, and 2, right? So that would be 1, 3, and 3. So that's right here. We add 1, 3, and 3 together. That gives us 7, right? Then we come over here to the same indices 0, 1, 2, and 3. That gives us 2, 1, and 3, right? So we're multiplying the minimum number out of these 3 in num2. Out of the 3 elements from nums2, we're picking the smallest one, which would be 1, and we're multiplying it by the sum of the 3 elements that we chose from nums1. So it'll be 1 plus 3 plus 3 equals 7. So we got 7 from nums1, and we're multiplying it by the minimum of the elements that we pick from nums2, which are the same indices, guys. So remember, the minimum element out of those 3 indices that we pick would be 1. So we're multiplying 7 because we added all those together, times 1 because 1 is the minimum out of those 3, and that gives us 7. So let's look. Let's say, look at this example. We choose indices 1, 0, and 3, right? So we choose indices 1, 0, 1, and 3. Excuse me. We choose indices 0, that's 0, 1, and 3. That will give us right here 1 plus 3 plus 2. 1 plus 3 plus 2 gives us 6, right? Then we pick the same indices on this side again, nums2. So 0 would be 2, indice 1 would be 1, indice 2 would be, or indice 3, excuse me, would be 4. But remember, we're picking the minimum out of this to multiply, which would be 1. So right here would be 1. That's the minimum that's the smallest number out of these 3 numbers. We're taking the smallest one and we're multiplying it by the sum of all of the numbers that we chose in num1. So in this example, it would be 1 plus 3 plus 2 equals 6, right? Multiplied by 1 because 1 is the smallest element or the smallest integer in nums2, which will give us 6, right? So let's look at another example. Let's go through all the examples so it makes sense, at least in example 1. Then we choose the indices. Say we choose the indices 0, 2, and 3, right? So y'all know what that's going to give us. That's going to give us 1. That's indices 0. Then the indices 2 is 3. So it'll be 1, 3, and 2. And that's where this comes from indices 1, 2, and 3. We add these together. That would be 1 plus 3 is 4. 4 plus 2 is 6. But remember, so we have new indices this time. So this time we have, on nums2, we have indices 0, which will be 2. Then we have indices 2, which will be 3, and indices 3, which will be 4. So now we're working with 2, 3, and 4. And we want the smallest one, right? The smallest element, or the minimum element, and out of those 3 indices, which will be 2. So then that's why we multiply it. 6 by 2 gives us 12. Then let's say we chose the indices 1, 2, and 3, and that will give us 3, 3, and 2. That's where this 3, 3, 2 gives us, right? So 3, 3, 2 gives us 8. So that's 3 plus 3 plus 2 equals 8. And then same indices on this side. So we will get 1, 3, and 4. We multiply it by the smallest one, which is 1. So 8 times 1 equals 8. That's why we get 8. Therefore, that's why we return the max score, which is 12. So out of all these different combinations, this is the one that gives us the highest score, which would be 12. And that's why the answer is 12. Then we come down and look at example 2. It's the same logic. It's just k equals 1 this time. Choosing index 2 will give us 10 times 3, which will give us 30. Because it's only 1, so we're just doing 10 times 3. Because that would be the smallest, or this 10 would be the smallest when it's only one integer. It's the only integer, so it's the only one we could choose, and that'll give us 3 times 10, which is 30. So that's how the question works, guys. That's how we're trying to solve for the highest score, and that's the logic behind it. So now that we understand that, let's see how we're going to code it. Now, the first thing we're going to do, since we're working with heaps, we're going to work with a heap in this question is, first thing we're going to do is we are going to import collections, because if you don't import collections, then you won't be able to use heaps, and heaps will not be in the scope. So first thing that's important we need to do is import collections. Then after we do that, we're going to come down here, we're going to say var current sum equals 0. That's going to keep track of our current sum. Then we'll say declare another variable called heap, and that we're going to cast that as a heap. Then we're going to say integer. Then we're going to close, we're going to put that inside the greater than or less than brackets, and then we're going to set that equal to dot init. And that is going to create an empty heap for us. That dot init creates an empty, initializes empty heap for us to work with. Then we're going to come down here, declare another variable called result, and we're going to set that equal to 0 as well. Then we're going to say for, open up the parentheses, we're going to say for nums1, comma, nums2, and zip nums1, comma, nums2. Now, if you've been on this channel before, you've seen zip before, and that's just going to set up pairs for and create pairs depending on indices between nums1 and nums2. Then we're going to come over here and we're going to say sorted by. So we're going to say dot sorted. Then we're going to say by. And we're going to open up the brackets. We're going to say $0.1. Then we're going to say comma. Oh no, we're going to say is greater than $1.1. And what that is going to do, that's going to get us the second element of the first pair and the second pair. So that's going to get the second element of both of the pairs, right? Then we're going to come down here and we are going to say, come down here and we are going to say current sum plus equal, plus equal nums1. And that's going to get us the sum of nums1. Then we're going to come down here and we're going to say heap dot insert nums1, right? Then we're going to come down here and we're going to say if heap dot count is equal to k, then we're going to say result equals max result, comma, current sum times nums2. And that's going to loop through all this for loop. Remember, it's going to loop through all the pairs that we need to loop through, and elements that we need to loop through. Then we're going to say current sum minus equals heap dot remove min. Then after that, we're just going to come down here, guys, and we are going to say return result. And let's run it and see how it runs. Hopefully it goes well. Fingers crossed, fingers crossed. Let's see. Boom, and it's accepted. So let's submit it and let's see if it's really accepted, because sometimes you'll accept the test case but not the real case. But this time it does, and it's 441 milliseconds, and it beats 91.67% of users with Swift, guys. So that's what I like to see. Those some good numbers right there. I hope to see you guys tomorrow for another day, another LeetCode problem. Peace.